First of all, I want to thank you very much for the invitation and the organization of the whole event. The first 2 days have been really a pleasure. I regret that I cannot give this talk in person right now, but COVID makes it happen. So it's a bit ironic to fly over the ocean and then give this talk via Zoom. Anyway, so at least in the first 2 days, many of the talks at this conference focused mainly on the question whether philosophy is useful for science, and less, at least that was my impression, on the vice versa in the title of the conference. And what I'm going to do is to discuss one way in which I think science can be actually useful for philosophy of science. And I do so by reflecting on some of the work that I did already a little bit, but that I'm more about to do together with colleagues from sociology and computational social sciences in the next couple of years. And I would like to answer this question, is science useful for philosophy of science, with a clear yes. But I'm going to take a very specific focus, namely the focus on the usefulness of methods from science. So using actually methods from the social sciences to illuminate philosophical questions. And in particular, I want to make the point that some of the computational methods that are used in other fields already and are used to analyze empirical data, particularly scientometric data, could eventually have a place in philosophy of science, I think. So my background is in philosophy of the social sciences, so I'm going to talk about a very specific social scientific method, namely empirical network analysis. And I'm going to say in a minute what that is. And in order to make the point that empirical network analysis might be useful for philosophy of science, I will look at least I think, a philosophically interesting phenomenon in science, namely model transfer in science. My starting point is the observation that there has been an increasing trend in several branches of philosophy, like, for instance, some parts of moral philosophy, of course, social epistemology, but also in philosophy of science, to use different methods from the sciences. For instance, there is literature on the use of formal models and simulation techniques, particularly in philosophy of science, but also philosophers have used experimental methods now quite a bit, particularly in moral philosophy. And then there is a literature now that uses qualitative methods from ethnography and anthropology, also in philosophy of science. And at the same time, philosophy of science is, in particular, has experienced what has been called, and what was also mentioned in the previous talk, a turn towards scientific practices, namely a turn towards doing philosophy of science by really closely paying attention to the practices that scientists follow to produce knowledge, with the goal of understanding those practices by investigating in detail representative instances of those practices, and then doing so mainly in form of studying particular what has been called case studies. And I'm going to say also in a moment what these case studies are. And then the idea of studying these practices in detail is then to draw some more general philosophical conclusions from them. And as a consequence of this practice turn, some philosophers of science, such as Wagenknecht and colleagues, have even talked about a trend towards an empirical philosophy of science, where the idea is really that those practices are to be studied with empirical methods and ground thereby, or help grounding philosophical claims or accounts or concepts in empirical research. Because oftentimes when you do this kind of research, when you use empirical or formal methods in philosophy, you get this question, why is this philosophy? How is this not sociology of science, or what have you? There have been some philosophers making proposals for why either formal or qualitative methods are useful in philosophy. So for instance, there's a recent paper by Conor Mayer Wilson and Kevin Zollman, who argue that agent-based modeling, that's the kind of scientific method of science that they are using. Why it's really useful to use agent-based modeling, because it's, as it is equivalent as they see it to traditional thought experiments. They think that agent-based models can fulfill the role of thought experiments even better, because when you use agent-based models, they think it allows us to make more, or it allows more rigorous reasoning and more transparent inference procedures and so forth. And others have made similar points for using qualitative methods to complement the traditional methods in philosophy of science in recent years. And so against this background, I would like to propose that some quantitative methods can also, quantitative empirical methods can also be of aid for philosophy of science in achieving one of its main goals. Namely, I think these kinds of methods can help to form and analyze concepts, which is a main goal of philosophy in general and philosophy of science in particular as well. And towards this goal, I take some computational methods from the social sciences to be particularly useful when they are used in a complementary fashion to what has been called this traditional case study methodology that is particularly used in philosophy of science in practice. And when they are in complement to each other, I think they can be fruitful. So what is the methodology of case studies? Using the case study methodology has been pushed by this practice turn that I've just mentioned. And of course, case studies are used in a variety of disciplines, and it's really hard to pin down a defining list of their features, what they actually are, because they have multiple features in different disciplines. But for, I think, the purposes of this talk, the three criteria that you see here listed on the slide, they're usually mentioned to characterize them, and I think they seem to suffice for this purpose. Just to give you an idea of what we mean by case studies. So first, with a case study, philosophers usually examine some period of knowledge production in considerable detail and take into account the context in which this happens, this knowledge production. And as such, case studies are often the study of historical episodes. So they are often historical case studies of knowledge production in a particular field or discipline. Second, a case study is always a case study for something. So when you do a case study, it requires that you answer the question, what is this a case of? So, and as such, a case relates the examined episode, so the period that you look at, the historical period that you look at, to a theoretical concept or a type of phenomenon that interests you and that you want to draw some philosophical conclusions about. So for instance, if you are interested in the concept of explanation, you look into a particular, or the concept of explanation in economics, say, you look into a particular historical period in which economists have given explanations. Maybe you look into what they say, what an explanation in economics is, and so forth. So you study this, and then you examine this in a context in which economic explanations are given, and then you draw some more general conclusions about what economic explanations actually are. And third, the concept or phenomenon of interest is often examined from a variety of perspectives when you do a case study, and sometimes, not always, by using a variety of methods as well, which might result then in a heterogeneous data structure. So for instance, case studies may involve empirical investigations. They might people might then, when they do them, also draw on archival work, interviews, do surveys, and so forth. And then if they do so, excuse me, this triangulation is often used to verify that the different perspectives are actually coherent with each other. So in that sense, case studies are often historical. They can be conducted by using a variety of methods, and they are so far used in the literature, or are classified in the literature oftentimes as a type of qualitative research. But I hope that I'm going to convince you, at least to some degree, that that does not have to be the case. They can also be classified as a type of, or it can also draw on quantitative methods. So the case study methodology is used nowadays in most of the core areas of philosophy of science. Here is a paper by Mizrahi, or some results that Mizrahi has produced in a paper, or presented in a paper, which shows that a large proportion of papers published nowadays in the main philosophy of science journals, such as Philosophy of Science, the BJPS, and the European Journal of Philosophy of Science, that articles published in those journals use case studies. And this is a trend that has started long before Thomas Kuhn. Thomas Kuhn was a philosopher/historian whose work really pushed for paying attention to historical cases. And that since Kuhn in the 1960s and 70s has just been a continuous trend, actually. And what you see here in this figure is that first, as far as research articles published in Philosophy of Science, so this is a figure that only analyzes the role of the number of case studies in the journal Philosophy of Science. As far as research articles published in the journal Philosophy of Science is concerned, the reliance on case studies has become significantly more widespread over the years since 1934, as you can see here, and that this upward trend line that is visible is also statistically significant. And Mizrahi shows that the same trend exists in all the other core philosophy of science journals as well. So you find a similar trend when you look at BJPS or the European Journal for Philosophy of Science. And second, what you see, or what he finds, is that the proportion of articles drawing on case studies in philosophy of science is almost half of all articles published in the journal nowadays. So at least half of the articles that are published draw heavily on case studies, and as such also on the case study methodology, which tells us that the case study methodology has really become an important method in philosophy of science. So what is the function of case studies in philosophy of science? Of course, when you look at the literature, there have been multiple functions identified, and they are used for in various ways. But if you want to consolidate a little bit, I think case studies fulfill at least three core functions in philosophy of science. So first, they can help us to generate philosophical concepts, theories, and claims. So I'm going to focus on concepts here. That's why theories and claims are in parentheses. But in general, they help us, generate our philosophical accounts. And here, the idea is really to take actual science as a source of inspiration, instead of just thinking about science from the armchair, as has been long done in philosophy of science, and thereby make sure that our philosophical accounts capture what is really going on in science. Excuse me. Second, if we already have a philosophical concept, case studies then can allow for their conceptual refinement, in that a case study can function as a test bed for those philosophical generalizations, or about concepts, for instance, or a general concept that you come up with. And they reveal when and where the actual science and scientific practices actually deviate from such generalizations. And thereby they allow the philosopher to refine and even revise these generalizations. And third, case studies are meant to give empirical justification for philosophical concepts. So once I apply my generalization to a specific historical case, and thereby show that it fits that case very well, meaning that it describes this case very well, or what's going on in this particular period, then I could take my generalization to be empirically justified, at least to some degree. So it has been recognized in the literature that case studies face a number of fundamental challenges in fulfilling those functions. And those challenges mainly concern the question how we should actually think about the relationship between cases and then these general philosophical concepts. And those challenges have been captured by the so-called dilemma of case studies, which was famously pointed out by Pitt in 2001 and has then from there on developed or elaborated upon further. And the general idea of this dilemma is that a case study is by itself particular. It's an individual instance of a scientific practice or an epistemic object or what have you. And however, the generalization that philosophers seek should be abstract and potentially also, of course, robust across many different cases. So if I come up with an account of explanation, I don't want to have an account that only applies to one particular case. I want to have an account of explanation that at least applies to all cases of explanation in economics. And Pitt and others have worked out this dilemma in a more specific terms. And the first horn of the dilemma says that if we start top down from a specific philosophical concept and then look for a case to exemplify or justify that concept, we are, of course, at risk of falling prey to selection bias or cherry picking. That is, we might choose a case that best fits our concept and then ignore other cases which we could have chosen, but that would potentially not have backed up or questioned our philosophical generalization. Excuse me. However, the solution to that problem is not that we can just stick closer to the facts, and that's the second horn of the dilemma. If we start bottom up from an individual case study, it's really unclear what exactly warrants our generalization. So if we study one or even a few cases, might not be really representative for all possible cases about which we want to formulate a generalization. And further, given the problem of induction and problems of underdetermination, we might not be justified in making these inferences. So to address the dilemma, we need to clarify really, or one goal has to be to think about what the relationship is when we between the case study and philosophy when we actually draw on case studies in our philosophical work. Ha-Seok Chung, who is a very prominent philosopher of science, who takes this idea of philosophy of science in practice very seriously, has responded to this dilemma by specifying how we should think about this relationship between cases and general philosophical concepts. And Chung argues really that the dilemma only emerges because we think of this relationship between philosophy and cases in terms of what you see here on the left-hand side of the slide, in terms of this traditional model, which presupposes a kind of top-down, bottom-up relationship where like a top-down, bottom-up relationship between the general philosophical level and then the particular level of cases. And here the idea is that the case is supposed to confirm or support the kinds of philosophical claims or concepts that you come up with. And Chung argues that's really the wrong model to think about this relationship. And he provides what is called here on the slide, on the right-hand side of the slide, the cyclical model as an alternative. And on this model, the relation between case studies and philosophical concepts has to be viewed as a continuous, like iterative process between abstract concepts and concrete episodes that instantiate those concepts, which you see here visualized by these round arrows. And on this model, we do not confirm philosophical concepts, but we articulate them and constantly refine them in light of new cases. And we study ideally as many cases as we possibly can to continue this iterative refinement of our concepts. And according to Chung, this relationship is then not a relationship between the general and the particular, but between what you also see on the slide, the abstract and the concrete, whereby the idea is really that the concrete can instantiate the abstract in multiple different ways, as long as the concrete cases share a set of key features across cases. And that's opposing the view that on the traditional model, that the particular case has to be a direct representation of the general philosophical concept or, account. And I very much like Chang's proposal, but there's an open question how this cyclical model is supposed to be, how this iterative process can be followed really in a systematic way to also ensure comparability between and some generalizability from cases. And I think that combining a multi-method approach by combining conceptual analysis, case study methodology, and computational methods that draw upon empirical data can ensure this systematicity actually, and thereby allow us to actually, get to this idea or realize this idea that is behind Chang's cyclical model. And I propose that empirical network analysis is one such method that could take on this complementary role. Now, what is empirical network analysis in a nutshell? It's really a method that so far has very rarely been used in philosophy, but has been widely used in sociology and history of science. And roughly put, it's a broad set of statistical, computational, and theoretical tools that are used to primarily study all kinds of relational structures between entities. And it thereby draws also, it does not have to, but empirical network analysis draws on empirical data when representing those entities and the relations between those entities. And what it does is that it allows to systematically analyze the properties of both. So we can analyze the properties of these entities and the relations between those entities in a kind of network. What is a network? A network, generally put, consists of two things. First, it consists of entities, like that. Those entities can be anything you almost anything you wish. Can be actors, epistemic objects, some physical event like a conference, can be institutions, can be publications, etc. And second, a network consists of relations among those entities or non-existing relations. And these relations can also be anything that you can envision. There can be collegial or co-author relationships, acknowledgement relationships. There can be, however, also similarity metrics. So for instance, there can be a relation between two publications if there's a topical overlap between those publications. And so these are the two kinds of things you need, and that's the kind of data then that you would need in order to actually come up and analyze a network. And empirical network analysis has been advanced in recent years to study science also, because of course we have now a huge amount of empirical data available about science, which is at the same time also of much higher quality than before. So it lends itself to analyze this kind of data. Excuse me. So on the right-hand side, you see one of the products of such a network analysis. That's a visualization of a study of the interconnections between and the influences of philosophers based on their similarity and differences, which has been conducted or constructed on the basis of data scrapped from Wikipedia. I don't want you to take this analysis too seriously. I just want to give you an idea of what a network might look like and what one product of this network analysis is. And in this analysis, Hegel turns out to be the most influential philosopher in the history of philosophy. I don't know whether that speaks for network analysis or whether that speaks for using empirical data from Wikipedia. Anyway, it's just an illustration of what that looks like. So now, by asking the question, what empirical network analysis can offer to research in philosophy of science against the background of this dilemma of case studies, the claim I want to defend in the rest of the talk is that empirical network analysis could be a method that helps to navigate through this cyclical process of Chang between concrete episodes and abstract philosophical concepts, and it can do so in a systematic way. And thereby it can help case studies to fulfill better the three functions that I mentioned before, that case studies fulfill in philosophy of science. So how can network and empirical network analysis do that? First, I think in order to see that, we have to first understand what Chang envisions by this cyclical process in greater detail. So he makes this iterative procedure more concrete by way of identifying this process of concept formation and refinement in 4 steps. So according to Chang, we can either start with a historical episode that we are interested in. Say we are still interested in explanation. We study historical episode where explanation is prominent in economics. Or we can also start with a philosophical framework. So we would start with some account of explanation that is around, that philosophers of science or philosophers of economics have worked on. And here we start from a philosophical account that exists. We might also come up with it. And then first we would check whether it fits a specific case or episode. So we might see that the framework, when we check that, does not help us to understand our case. So we have an account of scientific explanation that doesn't fit at all how economists in the, say, 90s have thought about explanation, or nowadays think about explanation, which motivates us then in a second step to revise this general framework, or even generate a new one if that's if that would give us a better understanding of this episode. Third, in light of the details of that case, we further develop and refine then our philosophical framework of explanation and work it out in greater details. And we do so by applying this to other episodes, to other historical cases, and then change it always in light of the analysis that we do there. And then fourth, if we can successfully apply our, say, account of explanation widely across different cases from economics, say, the study of each episode then thereby has functioned or functions then as somewhat confirming this account. But we do not aspire towards generality of this account. That's for Chang very important. So now Chang leaves open the exact details, how we ensure how this iterative process can be done, as I said before. And I propose that network analysis can actually help us in all 4 steps. But due to time constraints, and also because I haven't done the work yet of step 3 and 4, I will today only focus on the first and second step, namely to look at the historical episode, historical case, do the traditional case study methodology to understand that case, and then maybe generate a new or start to generate a new philosophical framework that is then to be applied to other cases. I want to show now, when we think about these 2 steps, as I mentioned before, I look at a very specific example or a phenomenon that might be interesting for philosophers of science. And that is model transfer. And model transfer has become really a key characteristic of modern science, I would say. So here is an example. For instance, if you take the Lotka-Volterra equations, which I'm sure you all know, this model was originally used to explain predator-prey interactions in biology, but then was quickly transferred into fields like medicine to study the growth of cancer cells, and also into economics to study the business cycle. And when you look further, modern science is really full of such examples. I'm not saying that's a new phenomenon. It has always been there, but it has become more prevalent in recent decades. And a philosophically interesting question that emerges here is, how are these models actually transferred across domains? So how can we explain these transfers? given that we often think of models as really representations of their target systems, and thereby in a specific way also constrained by these target systems, and which means that intuitively and on first sight, they might not be applicable to a wide range of fundamentally different kinds of target systems. So what would be then, if we start a la Chang now, what would be the puzzle or the interesting thing about this, the philosophical framework that we could start with? And someone who said something that might be useful for further thinking about this was Thomas Kuhn. However, I should say that is Thomas Kuhn in his very, very early work. His paradigm theory came much later, which was a refinement of that idea. But very early on, Kuhn acknowledged that, innovations, scientific innovations, including model transfers, and that's I take Kuhn to study model transfers. He didn't talk about model transfers directly, also not in his early work, but I think it's a useful starting point here. So he thought that when scientific innovations emerge and they are transferred from one domain to another, that can be really a catalyst for progress in a field. But in order for that to be progressive, model transfers need to really overcome what he called an essential tension. So on the one hand, the model that is transferred has to be innovative and novel for the target domain into which it is transferred. And then in order to become novel, or to be novel for the target domain, it has to, of course, keep elements from the source domain, because that's precisely what makes the model novel for the target domain. But the model needs to also be the model needs to be adapted to traditional frameworks of the target domain in order to become accepted. So we won't introduce or transfer a model into our domain if it doesn't align at all with our theoretical commitment or methodological commitments and epistemic values. So to some degree, it has to be integrated into what's already there in the target domain into which the model is transferred. And so model transfers have to be presuppose some kind of balance between innovation and tradition in order to be successful. And the philosophical question of this example then is, how is this tension resolved in practice, actually? That's the thing that I would like to get out of the kind of case study that I'm going to look at. So Kuhn, in a very early lecture that is called Essential Tension, or is entitled The Essential Tension, Kuhn himself talks a little bit about that. And he argues there that this essential tension can be overcome by a specific modification procedure of a new model. And again, he doesn't talk about models. That's my application of these early Kuhn's idea to my case. So he talks about that the essential tension can be overcome by a specific modification procedure of a new model that consists of what he calls translation. And again, he changed his mind later on and refined this idea when he developed his paradigm theory. So when something like the Lotka-Volterra model is transferred, that's the idea, from one source to a target domain, the model is modified such that it contains traditional and novel elements from both the source and the target domain, and thereby overcomes the essential tension. And this is a process of modification, label, translation. And the problem is that Kuhn's notion of translation is really defined very loosely. You can't really apply it to any concrete case. He didn't talk too much about that further. So the goal here would be then to get a more precise and reapplicable and justified philosophical concept of translation to capture this modification process that then partly enables us to explain model transfer. And this is what I did by first analyzing a very concrete episode of model transfer, and then and use thereby the traditional case study methodology, and then complement this analysis of the same case with empirical network analysis. Okay. So to start this process of concept development, I take this general concept and apply it to a historiographical puzzle, or to a and that's Chang's terminology, puzzle, but it's really just a concrete historical episode. And in our case, this is the transfer of rational choice models across the social and behavioral sciences. And this is a very successful case of model transfer that took place in the second half of the 20th century, where rational choice models spread into all the social and behavioral sciences and beyond, into biology and medicine and so forth. And those models originate in John von Neumann and Oskar Morgenstern's book, A Theory of Games in Economic Behavior. And that laid really the conceptual grounds for rational choice models across all the social and behavioral sciences. And they made two important contributions in this book that allowed people later on to build mathematical models of individual choice and social interaction based on the idea of rationality. Which was the first contribution was the axiomatic formulation of the principle of expected utility theory, and the second one, a theorem, the details are here not so important, that was supposed to be a rule for rational action in situations of strategic uncertainty, and that then allowed to actually not only model individual behavior, but also, strategic interaction between more than one agent. This historical episode or case, there's quite some literature on this history of this kind of model transfer, and I started to look into this episode in greater detail. What I saw from existing historical accounts was that of course, this widespread of rational choice models. So you see here on the slide how the outcome of the transfer process of these models based on the contributions made by von Neumann Morgenstern looked in the 1970s, and all these different disciplines adopted rational choice models, from statistics to economics to psychology to political science and beyond. And rational choice, or these contributions of von Neumann Morgenstern, even laid the grounds for new fields where operations research and linear programming, where these kinds of models were also used in a different way, but they were there. They laid the ground for these fields even emerging. So how did those models overcome the essential tension to get there? And how can we think of this process? Can we think of this process as one of translation? So then I went and studied the historical details of this episode further, of a couple of transfer processes. For instance, the case of transfer, rational choice models transferring into political science and into economics. I studied the social, institutional, and epistemic context of the model's origins and the transfer process, the relevant scientific contributions. So what kind of publications were actually taking those contributions up? What did they do? In which way did they engage with von Neumann Morgenstern's contribution? And who are the actors making these contributions? And from studying this historical case, I could then make some rather ad hoc observations about the kinds of scientific contributions that seem to have played a role in enabling these transfer processes via some form of modification or translation. At least that's what I got a sense of. This is how I first got the idea in general of using Kuhn. So there was a back and forth between philosophy and history here, actually. So first, there were initially, that's what I saw from when I studied this case, there were initially only very few scientific contributions or publications from within these different social and behavioral sciences that adopted rational choice models. So very few people did in their publication do something with these models. And those contributions were also, when you looked into them, into these publications, they played really central roles in pushing the development and transfer process further. So it was clear when you read through them that they wanted to push these models in their respective disciplines in some way. But at the same time, the different contributions that I looked at seem to also play, or the kinds of roles that they play, they seem more nuanced. These roles were different in kind, I thought, in enabling the transfer. They played also different roles at different stages of the transfer process. Some, for instance, only engage with von Neumann-Morgenstern's contribution on a very formal level. They would elaborate on a certain proof or simplify the mathematical formulation behind what they had done. And others really try to think of more concrete problems in their own field to apply those contributions. And how, and even others, they were really thinking, how can I actually use the vocabulary, say, of political science to formulate those highly mathematical game schemes that von Neumann came up with in such a way that political scientists would actually understand them. And finally, so there were different kinds of roles these publications played. And then finally, some of those contributions, by reading them, it seemed to me played some kind of brokerage role between these mathematical contributions that von Neumann had made and the people who elaborated upon these contributions on the mathematical level, and then between them and the field that that they were, that the authors of those contributions were originating from and wanted these models to actually apply to. So the question was, what exactly is the role of those publications, and can we distinguish these roles in some kind of systematic way to then see whether some of these publications had this translator or modification kind of role? Here is just a list of some of these brokerage publications that relate to the slide that I showed you earlier, where you could indeed see then every field that I identified on the basis of this historical count into which those models spread had a kind of publication which played this brokerage position. So for instance, if you take here Ward Edwards, he came up with these two publications, and the theory of decision making and the other one. And if you read them, you see that he tries to use the vocabulary of mathematical psychologists to actually work on those on the expected utility theory, but also on the game schemes that von Neumann-Morgenstern had proposed, to make sure that psychologists would understand them and also see how they could apply those to concrete problems in mathematical psychology. And you see, for each of those, I thought, okay, here's this kind of publication that plays this brokerage position. Now, usually you would stop here. When you do traditional case study methodology, you would only identify and describe those roles, probably anecdotally, the different kinds of roles that you might have identified, and then you would identify the one that has these brokerage, the ones that had this brokerage role on an anecdotal level. But you would not really be able to know whether you identified all the domains into which rational choice models got transferred, whether we identified all the relevant contributions. You wouldn't know how to strictly classify them, because you wouldn't have a criterion of how to systematically select them and define those kinds of roles. And then it would, of course, not be so easy also to compare across those different kinds of publications and compare the different kinds of transfer processes into those different areas. But if you want to abstract from this particular case to more general philosophical concept of translation or modification in the case of model transfer, this is what you would want to do, I think. So here, empirical networks analysis, I think, can help. So network analysis really, in this case, allows us to trace this transfer process of rational choice models in this particular case. And we can see whether we can identify and characterize the main scientific contributions or publications that adopted these ideas of von Neumann-Morgenstern, and whether we can do that in a more systematic way and categorize them according to different kinds of roles that they might have played in this transfer process. And what we did was we did a co-citation analysis of relevant publications using rational choice models originating in the theory of games. And I'm not, due to the time, I'm not going into the details, but very quickly, I'm going to say how we gathered the data and what we got from the analysis. So what we did was we used the Scopus database, and we selected all articles published between 1984 and 2014 that cited the theory of games. So this is a modern, so this is the period nowadays. And these were in total 4,905 papers and books. And we did so, we had to work with this period because there is no reliable citation data available from the years 1944 to 1984, which is the period that we are actually interested in. And what we did was we identify all the citations contained in those 4,905 papers and books, which were roughly 200,000. And of these, we selected all those citations that refer to papers and books published between 1944 and 1970, so the period that we are interested in, because and that way we got the contributions that have been published in that period and that are still nowadays co-cited with the theory of games. So these were actually books that are cited nowadays that are published between 1944 and 1970s. And as such, as they are cited and co-cited together with the theory of games nowadays, they can be considered classical or seminal contributions in a field. And this generated our data set, which consisted of 1,967 unique texts that are cited around 18,500 times in total. And on the right side, you see the final network that we created on the basis of this data. Also here, without going into the details, this network is created, of course, by a number of rules, mainly two rules. First, that if the first rule is that if two publications have three or more co-citations in publications published between 1984 and 2014 and are less than 5 years published apart, that's the second rule, then two publications are actually connected. And that the idea is to capture not only that co-citation with the co-citation together is that there's a co-cited 3 times, there's a topical overlap between two publications, and this is why there's a link, but then also that these publications are not more than 5 years apart, but because if there were a transfer from one publication to another seems to be a bit implausible. And the notes here, these gray points, they represent a scientific book or an article that engage with von Neumann's theory of games, of course, and the relations between them then signal that two articles have been co-cited in that book. And at the same time, fulfilling those two rules. So without going into further details, what were the steps that we took then, and what did that network analysis give us? So first, what we did on the basis of this data that we collected, we constructed the aforementioned the network topology that you saw on the previous slide. That consisted then of all relevant scientific contributions that we consider classics, made in form of books and papers that adopted rational choice models between 1944 and 1970s to not to trace that transfer, but to represent it or visualize that transfer or mapped this transfer. Second, we took this topology then to represent the outcome of the transfer process in form of clusters. That's the topology that you see here, this clustering effect. And this is supposed to represent contributions from different fields. So each color here on the slide in this topology represents different disciplines into which rational choice models got transferred. By using some clustering algorithm, we identified clusters of publications that belong to the same field. So the little, 5-node cluster that you see on the top, the violet one is, for instance, evolutionary biology, but the big one, the green one, is economics. And so we could cluster these publications according to the fields and got, I think, 13 fields in total. Third, into which those rational choice models spread. Third, by using other algorithmic procedures, we could systematically classify different kinds of key scientific contributions in those fields on the basis of features they shared with respect to their network positions and their network properties. And then finally, on the basis of their shared network positions and properties, we then could define the roles of those contributions that had these shared positions and properties in the transfer process systematically. So we could identify different kinds of publications according to these network properties that they had and put them together and say what kind of role they played according to those properties. Which brings, of course, a high level of systematicity in this whole analysis, in that we use rule-based procedures and plausible algorithms or measures to define and analyze the roles of these different kinds of contributions. So the result of this analysis was then we got a large overlap between what we got from the historical case study analysis. But there were also deviations. So some of the publications that we identified as having being very important, we didn't consider them in our historical analysis as very important, and vice versa. And now now we have this whole case study analysis by using the historical work, doing the historical work, but then also using network analysis, and now going to the conceptual level, the philosophical level. And what we could do now on the basis of this analysis is we could identify 4 kinds of roles that publications could actually play in this transfer process on the basis of the network properties and positions that those different publications actually occupied in the network. And because I'm over time, I'm just going very quickly here, that the point of this slide is to see that we not only could characterize the different steps of the transfer process by saying there is an innovator that comes up with a new set of models, then there is an elaborator contribution that elaborates on these new set of models on the very general level, say on the mathematical level. Then there's a translator contribution that actually tries to bridge the gap by giving, for instance, new interpretations, modifying these models in such a way that its field understand what kind of problems they can address in a specific field. And then there is a specialist role that is the role that those publications play, that actually take those elaborated and translated models and apply those models then to particular problems in their own field. Say, maybe that's comparable to Kuhn's idea of normal science. But the point here is that we could not only, describe these roles verbally, but we could also describe them very systematically by, in terms of the kinds of network properties that those contributions have to have in order to fulfill those roles. And if you take the translator role now, you can see what kind of network properties and positions the translator has to have. Namely, it has the translator contribution has to have a high connectedness among those contributions in the field that are specialists that apply these models eventually, but also has to be very highly connected among those early adopters that elaborate on those models in the first instance. Sorry, I'm fully out of time. I'm trying to wrap up. So what is the contribution of network analysis then here when it comes to the systematic iteration that Chang envisions? How can we summarize this? I think we can see now that the main contribution really is to enable a cyclical yet systematic iteration between the concrete and the abstract that Chang's model presupposes. If we were now to apply this exact same procedure, the exact same analytic procedure computational procedure to other kinds of cases of model transfer, and also identify elaborators, translators, and so forth, according to the exact same properties that we identify they have to have. So what we did, just to wrap up, we started with a philosophical concept of translation introduced by Kuhn that was general and vague, and left room for misinterpretation. And then by studying this concrete case with not only with the traditional case study methodology, but also with empirical network analysis, we are now in a position to actually select and analyze comparable model transfer cases systematically, by defining and then applying these rule-based procedures of not only for data collection and data analysis, but also for identifying these different roles. We can ensure that the cases that we select and analyze are comparable when we want to understand the translation or modification procedure. Second, it helps to systematically refine a concept like the translator concept by allowing for its repeated replication to other historical episodes according to the same technical criteria for the analysis. A network analysis really enables a continuous refinement of this translator concept, but also continuous refinement of the analysis, or this rule-based procedures that we apply itself. So it's a back and forth between, the conceptual refinement and also the refinement of the computational procedure in light of new cases. And third, applying the translator concept via a very systematic rule-based reapplication of the same computational procedures to more episodes than would be feasible without using network analysis, because we can't do all this historical work always for many, many different cases. We can thereby enable this refinement. We can, however, also provide much more empirical justification, or a higher degree of empirical justification that we could usually do otherwise. And finally, this iterative reapplication of rule-based procedures to different episodes might ensure also some degree of robustness of the accounts or concepts that we come up with, and allow for also procedural revisions ultimately. But that's what I said before. Sorry, I'm really over time. I think this is basically what I just said in more general terms. I think the point is that ultimately network analysis is useful for philosophy of science, because in light of what I just said, very quickly, admittedly, it is useful for philosophy of science because it really allows case studies to better fulfill their three functions, as I tried to illustrate in the particular case that we analyzed. And this is just a summary of what I just said on a more general level. Thank you very much.
Yes, thank you. We have some questions. We have time for questions. Yes, please.
So I was very much interested by your talk, and I wanted to bring some remarks. My general intention is to add something to your two philosophical references, which are Kuhn and Chang. I heard you. So my point is simply that in what you said, and starting from Chang, because Chang is showing a circle of the interaction between the concept and the cases of the concept, more or less. the universal and the particular. And so this idea that there has to be an interaction between universal and particular is something which has been underlined by all hermeneutical tradition. And that's what I wanted to bring to you. I think that in your work, it's a way of reviving hermeneutical tradition. Kuhn is clearly connected in ways with hermeneutical tradition because this issue, this essential tension between being innovative and still following the internal norms is exactly the tension which is elaborated by hermeneutical trend since the beginning. Your great hypothesis, as I understood you, is that you are not completely satisfied with Planck's circle. And by the way, I remind that circle is internal to hermeneutical tradition because we all know the hermeneutical circle. You are not satisfied because you see that Chang understands that there has to be an iteration of this back and forth between universal and particular, but you would like this iteration to be in a way immanent to some reality. Let us say this interaction should be given and materialized, and that's what you get with your network. And still it's not exactly the same level, but I think it's convincing. And even the application, the first application you offered with the Locke-Volterra equation, I think it's a general form of which Van der Pol equation is a case. And I know that I had discussions with a mathematician friend who was working on the transfer of this model, and he was seeing it in a kind of hermeneutical way. So sorry to be a bit too excited, but I have the feeling that I have projected something with some legitimacy on your proof.
So I take this as a comment. I gather that there were other questions. I don't know, we don't have so much time. If you want to, or
yeah, thanks, Catherine. So I had a question about model transfer and the role that translator plays. So the way you describe model transfer in the talk is that it's got to navigate. It involves navigating these tensions between, right, the target and the origin, but it's not exactly clear what it means to navigate tension or what that tension is. And it strikes me that an interesting testable hypothesis, at least that your paper sketches out, is that if you look at the papers or the books that occupy the role of translator within the epistemic networks, you could then do some further analysis on those both, right, textual analysis or structural analysis to see, right, are they doing are they doing things with the formatting or the way they're talking about subjects that actually are navigating a tension there, or are they just doing something in the style of economics, but for whatever reason, you know, the philosophers are starting to cite it, or the evolutionary biologists are citing it, even though it's not structurally different.
yeah, that's exactly right. That's so what I don't mean to say is that network analysis that is somehow conceptual analysis or something of that sort. So obviously the philosophical work now actually starts only. What the only thing that you can do with network analysis is you can identify these different kinds of translators, and then you would now go into the details and study what these contributions are about. But the nice thing about this is that you have criteria, you have a definition of what a translator contribution looks like in terms of these network properties that gives you criteria for identifying the kinds of contributions also in other cases. So you have what you can do is you identify a whole bunch of different kinds of translator publications or contributions in different kinds of cases of model transfer. And then, of course, the philosophical work of what this modification looks like on the conceptual level has to get started. But then you can compare better. And this is the idea that when you have more, you can see, oh yeah, these are playing all these roles. Do they all the same thing, or do they do a different thing? And so you start analyzing, come up maybe with one account of, with one concept of translation, and then you study, you know, go into more and more of these contributions, and then see, well, I need to refine this concept in light of the fact that they are all these translator contributions. Does that make sense?
Thank you. Are there other questions? Yes.
Yeah, thanks a lot for your talk. I'm going to question the other side of your presentation, which is the notion of case. In fact, you wanted to address the issue of how science can be useful for philosophy of science, and you focused on the experimental network analysis. However, it seems to me that the issue of how you deal with cases is also an issue that is met with in the context of several sciences. There are many sciences that select cases, choose between cases, and there is a whole reflection of in the context of what you do with it. So do you see another possibility of interaction between science and philosophy of science on this other side of what you presented?
Oh yeah, sure. I mean, I think there are multiple ways in which science can be useful for philosophy of science. I mean, I'm very interested in general in methodological questions, and also using different kinds of methods to illuminate philosophical questions. And I guess there's a whole variety of methods that are interesting and useful for philosophers of science to use when they do philosophy of science. So it really depends on the kinds of questions that you have, the things that you are interested in. And I think just in this particular case, or in the, you know, for the way in which you do case studies, when the thing that you are looking at lends itself to also conduct an empirical network analysis, then I think it's useful. But it's not, of course, it's not a cure for all kinds of problems, and for I don't mean it to say, well, you know, that's the only method that can be used. It can be used for everything. But maybe I misunderstood the question. So I think the point I want to make in general, I find all sorts of scientific methods useful to be applied in philosophy of science, in light of the fact that we're having these movements of philosophy of science in practice and empirical philosophy of science that I take to be very valuable and you know, worthwhile endeavors, which shouldn't diminish things, you know, research programs in philosophy of science that don't necessarily need to look at practices. There are also other problems that you can address where maybe looking at practices is not so important. But for those that are important, scientific methods, I think, can help quite make a big difference.
Thank you.
Yes, first of all, thank you very much for giving this talk from 200 meters from the conference. This is really strange, but thank you very much. Second, more on your talk. I have to confess that for me, always quite difficult to well understand this notion of case study. If my opinion is the following: if philosophy of science is really a philosophy of something, so it cannot be other thing than philosophy of a reality that is the reality of science. it is a reality of science and cannot be other thing than an historical reality, what history gave to us. And so it seems to me that this is not something that philosophy can do or study historical study. It's the only thing they can do. So I don't see what philosophy could do other than try to look to philosophy of science, of course. I'm not speaking of philosophy in general. That looking at what happened, what is the reality of science that we are studying, and work with respect to it with a methodology that cannot be very different in the end of the story with a methodology of an empirical science. Because this is what it seems to me that the philosophy of science is required to understand. The way in which science not should be, will be, but the way in which science is and what makes it is particularity. So this is not to make to criticize your talk, at the contrary, to see that what you are suggesting here is at the end of the story all what philosophy of science should do in a way or another. But this is the point. It don't seem to me that is one of our tasks. Is our task.
Well, I mean, I'm not sure if everyone agrees in the sense that, of course, for a very long time and still at this point, parts of philosophy of science is a normative, are normative endeavor. So the idea being that...
This is exactly what I disagree with.
Yeah,
I mean, the science does not very well what they have to do. They do not need philosophers to explain them what they have to do as scientists. In some sense, of course, philosophy can contribute. The philosophical reflection as an interaction. This is the sense of our discussion. But this is another story. Philosophy of science as philosophy of science. It seems to me that it's not here to explain what science is to do. It's to explain what science is. But in any case, this is my opinion, and I don't pretend that you agree. I know that it's a very particular opinion. I want simply to make it clear. I think that philosophy of science in the end of the story as an empirical science section. I
guess an important, if you have this, if you take this kind of position, an important question that one should be able to answer then is, you know, in which, so what is the distinctive, you know, characteristic or goal that philosophy of science pursues? Because of course, I mean, I get a lot this question of how is this not sociology of science? And I think parts of what I do is sociology of science, and that's fine for me. But as I said before to the other question, I think the philosophical work would now start, and you would actually try to think about a more general philosophical concept of translation, if you will, or this that captures this modification model transfer. And that is, I mean, conceptual analysis is in that way partly normative. And so if you deny this kind of project, then I mean, that's fine, but I think it's debatable. And what I thought was very interesting, what I got from the first 2 days of this conference was that many scientists who gave talks said, you know what, philosophy of science can actually help with conceptual clarity. And I think that's still a very important endeavor. And I think we don't have to abandon this, however, if we do empirical work, we can have both. And I hope to combine both in this kind of project.
But well, continue a discussion indefinitely. But I do not see that there is contradiction. Of course, a science has a conceptual role. Making a science means to explain, not only to describe, not only to make a photography. So when I say it, I absolutely not denying that there is a conceptual role, a fundamental role. And it is exactly what any science do, to try to explain and to describe the reality within a conceptual schema. So I don't think that in this way you think that philosophy as an empirical science is in some sense a way to diminish the role of philosophy. Exactly the contrary. Exactly the contrary, is to make the philosophy, to ask to philosophy to conceptually understand what science is. And in doing that, of course, it can and should, it is very good to contribute to science itself. But I do not see a sort of abstract reflection that philosophy of science should have about science if science is not the reality of science and that is given to us by history. Okay, okay, can stop.
Perhaps we take this conversation offline, and thank you very much. Let's thank the speaker again.
Thank you very much for listening.